if A, B and C are in GP, show that 1 upon A plus B, 1 upon 2B and 1 upon B plus C are in AP. So let's see how to do it here. Now if we have, say, X, Y and Z are in AP, so what do we get? We get Y minus X is equal to Z minus Y. If I bring Y this side and X the other side, becomes what? Y plus Y is equal to X plus Z. Means 2Y is equal to X plus Z. Means the middle one is 2 times is equal to sum of the other two sides here, other two terms in it. Okay, the first term and the third term in it. Same thing here. If these three are in AP, 2 times this will be equal to sum of this plus this. Okay, so this is the middle term, this is the first term, this is the third term. So twice the second term is equal to sum of the first and the third term. Remember, so we can use this here to solve it, and you can say we can start this with. Okay, so let's write it now. How do we write it? So we will write it like this. So what we can say is that if A, 1 upon A plus B and 1 upon 2B and 1 upon B plus C are in AP, then what will happen? 2 times the second one, this is the 2 times the second one here, right, will be equal to sum of the first term and the third term, sum of the first term and the third term. If I solve it, this 2 will get cancelled, so 1 upon B is equal to 1 upon A plus B plus 1 upon A B plus C here. Now what I'll do is I will take the RHS in it, which is 1 upon, I can take it here, fine, I'll just take it. Okay, in fact I should take only the RHS here. This is the RHS, and I will solve it and prove it is the LHS from here. Okay, this is the one. So I'll prove that this is equal to 1 upon AB, 1 upon B. Before we move on, they have given that A, B, C are in GP. So what we can do is, then using the GP laws that we have, that is B upon, okay, the first term is, okay, A, second term is B, and third term is C in it. Let, we can say that let the first term be A. Since A is already there, so we can take it as a capital A in it. Okay, we may not take the capital term, a capital A here. Let's take the small a only here. So if the first term is A, if I take it as A only, and considering that let the common ratio be, let common ratio be is equal to R in it. So the second term will become what? AR. Third term will become what? AR square. Remember how is that? A to the power n minus 1. Sorry, AR to the power n minus 1. So it's the second term, so 2 minus 1, and this is 3 minus 1. Okay, 2 here. Now we got these 3 terms in it. Okay, so which means wherever is A, I can substitute A. Wherever is B, I can write this. Wherever is C, I can write there. Where? In this particular equation. So if I do it, what do we get? So it will become 1 upon A is what? I'll keep only A. B is what? B is AR. So I'll put here AR. All right. Now plus 1 upon, what is B? AR plus C is AR square. Okay. If I solve it further, what will become? I can take A common. What is left? 1 plus R. Here plus, I can take AR common. What is left? 1 plus R. Now I will further solve it here. So if I take the LCM will be AR into 1 plus R, right? So if I take the LCM, I write it here. AR 1 plus R, okay, is an LCM of all this. The highest degree of everything in, right? So if I divide this by the first one, what do we get? R. So I'll divide this by the denominator of the first fraction. What do we get? R only. So write R. Now this is a plus. I'll write plus here. Then after that, what we'll write? If we divide this by this one, I will get 1 only. Fine. Now further I solve it. It becomes, I can write R plus 1, and here is AR 1 plus R. R plus 1 and 1 plus R is the same thing, right? Or maybe if you want, I can just write this as such. 1 plus R is what? Same as R plus 1. So I can write here 1 plus R in it. 1 plus R and 1 plus R will get cancelled. What are you left with? You're left with only 1 upon AR. 1 upon AR. Now, what is AR in it? Can you see? AR is B. So I can write is equal to 1 upon B now. So, have I not got the first? This is what we solve, and we got what? 1 upon B. And this is possible only when this is an AP, right? So we have got the LHS. So therefore we can say that yes, this is how we can prove it, right? This is how we can show. So we can say hence proved.